Hello everyone. Today we're excited to walk you through our detailed exploration of portable camping stove sets, a product that might seem simple at first glance, but in reality represents an impressive convergence of mechanical engineering, material science, and human-centered design. Let's begin with a bit of history. The concept of the portable stove dates back to the early 1800s. Pioneered by French chef Alexis Soyer, during his time in London, Soyer developed the Soyer stove, which revolutionized field cooking for military troops and travelers. This early innovation laid the foundation for a tool that would later become vital for outdoor survival and modern adventuring. Today, portable stoves are indispensable for a wide variety of users: hikers scaling alpine routes, campers setting up in a dense forest, emergency relief workers operating in disaster zones, and even students heading out on spontaneous weekend getaways. These stoves must perform reliably in unpredictable and sometimes extreme conditions, be it high altitudes, strong winds, or damp terrain. And their design must reflect those challenges. Camping stoves can be classified primarily by fuel source and structural design. As you can see from the graph in here, we classified the stoves by their fuel sources. Gas canister stoves, which use fuels like butane, propane, or isobutane, are widely popular for their convenience and fast ignition. Liquid fuel stoves performs exceptionally well in cold, high-altitude environments, and multi-fuel stoves offer great versatility, capable of using both liquid fuel and gas canisters, which makes them ideal for long expeditions across different regions. In our project, we focused on a gas canister stove, equipped with piezoelectric ignition and foldable pot arms. This particular configuration stands out for its portability, minimal setup time, safety features, and wide applicability for both recreational and semi-professional use. From an engineering standpoint, designing a stove like this requires a careful balance between safety, performance, and user-centered considerations. It must be lightweight yet durable, thermally effective yet wind resistant, and compact yet easy to use in harsh conditions. Thank you, and now it's my friend's turn.
Now let's move into the material selection. Because a product that must endure fire, pressure, and rough environmental exposure, what is made of is absolutely matrix that weights mechanical strength, corrosion, resistance, thermal conductivity, weight, manufacturability, and cost. The burner head is constructed from stainless steel, chosen for its high heat tolerance and excellent corrosion resistance. Pot support arms are its exceptional strength to weight ratio, which is ideal for product foldable portable structures. The fuel inlet pipe is produced from brass, which combines corrosion resistance with easy machinability, essential for pressure-treated parts. The control wave integrated stainless steel with rubber steels, ensuring both mechanical strength and gas-tight sealing. System uses ceramics for insulations and steel for the hammer mechanism, allowing the thousands of reliable ignitions for this base frame and housing. The die-cast aluminum is used, offering both rigidity and the ability to form complex geometries. Finally, the blind shield is built from perforated stainless steel sheets, striking a balance between heat control and structural integrity. These materials are carefully matched with the fabrication techniques that will shape them. Let's talk about the beginning of the process, cutting and bending. Laser cutting is used for high pressures, parts like gas distributions, hose, and pot support arms. Water jet cutting is employed when thermal distortion must be avoided, especially on softer materials or composites. Then come bending techniques. Press brake bending allows for consistent angular shapes in pot arms. Stretch. Roll bending is used for windshields, panels, enabling them to redirect airflow efficiently. while maintaining a cylindrical shape that's resistant crinkly. These steps ensure components are not just functional but also optimized for durability, weight, and safety in demanding outdoor environments. And
Okay.
that's
Continuing from the fabrication stage, we now focus on the core manufacturing techniques that transform these materials into a fully functional camping stove. These techniques include welding, stamping, forming, and finally assembly. Welding is vital for joints that experience high thermal or mechanical stress. TIG welding, for example, connects the burner heat to the base, creating a clean, gas-tight seal that can withstand repeated heating and cooling. Spot welding is used for thinner components like the heat shield or base plate. Stamping techniques are employed to create airflow vents, branding, and imposed guides for easy alignment and assembly. Forming methods such as hydroforming and incremental forming are applied to develop complex curves and 3D geometries, such as burner domes or rounded. This helps maximize efficiency and safety without adding unnecessary weight. After all components are manufactured, the assembly process begins. It starts with pre-assembled subunits like the burner, ignition module, and control valve. These are mounted onto the base frame, and the foldable pot stands are installed using riveted hinge pins. Fuel buffers are pressure tested with nitrogen to detect micro leaks. The piezo igniter is tested to ensure consistent spark delivery. The control knob is rotated across its entire range to confirm precise flame modulation. Each unit undergoes a full burn to test and to check for stability and flame quality, and units are dropped from 1.5 meters to simulate field conditions. Reignition and sustainability flame performance are assessed post-drop. Once all quality benchmarks are met, the stove is folded, packed, and user manuals and sealed inside protective.
Now, we reached the final and equally vital stage of the product's life cycle: quality control, sustainability, work safety, and our closing thoughts. Given that the portable stoves involve leaves, flames, and pressurized gas, strict quality control is non-negotiable. Each component is inspected using micrometers and calipers and dimensional accuracy. Words are tested visually and through the bi-penetrate method to detect cracks. Gas valves undergo helium leak detection under vacuum conditions. Fully assembled units are checked for consistent flame shape, proper modulation, and ignition responses. International standards like ISO 23550 are followed to ensure safety and compliance. Beyond the performance, modern manufacturers are increasingly prioritizing the sustainability. For instance, aluminum shavings and brass cutoffs from machining process are collected, remelted, and reused. Powder coatings have replaced traditional paints to reduce VOC emissions. Many stove designs now support the biofuels and come in the recyclable or biodegradable packing. Some companies are even implement take-back programs, encouraging consumers to return worn-out stoves for proper recycling instead of discharging them in landfills. Worker safety is another core consideration, assembly personal wear gloves when handling sharp edge or heat-sensitive parts like ceramics. Welding stations are equipped with fume hoods and ventilation system to minimize the exposure to harmful particles. Optimization is used wherever possible to limit human involvement in hazardous tasks. In conclusion, manufacturing portable camping stove is about much more than creating a product. It is about creating trust that the device will work when needed most in extreme and often life-dependent conditions. From concept and material choice to manufacturing techniques and sustainability practices, every decision in this process is made with the precision and purpose. These stoves represent the seamless integration of design, engineering, and environmental responsibility. Whether used on a mountain ridge, a forest campsite, or in an emergency response zone, stove must be ready to perform. and it is because of everything that went into making it.
Thank
Thank
you
you
for
for
listening.